Before you close your eyes tonight, imagine the universe as something alive, not still, not empty, but breathing in slow motion. Between its glowing filaments of galaxies lie vast oceans of nothing, silent and unseen. And in one of those oceans, one of those enormous voids, that's where we are. Welcome to Science Reshaped, a quiet place where we drift through the mysteries of existence and let the universe whisper its secrets. If you haven't already, take a moment to subscribe, settle in, and listen closely. Tonight's story is about where we live, not just on Earth, not just in the Milky Way, but in the strange hollow at the heart of cosmic reality. Most of us grow up thinking the universe is evenly filled with stars, an endless glittering ocean of light stretching in every direction. But when scientists began to map it, they found something startling. The light is not evenly spread at all. Galaxies gather into threads and clusters, woven together by gravity, leaving behind immense empty spaces between them. What emerged was a pattern, a kind of cosmic web, where luminous matter forms the filaments and the dark gaps between them are voids. And our home, the Milky Way, sits right on the edge of one of these invisible hollows, a place scientists call the local void. A void sounds simple, but in truth, it's one of the strangest things we've ever discovered. It's not just empty, it's vast beyond imagination, spanning hundreds of millions of light years, containing only a few lonely galaxies drifting in the dark. If you could step back far enough to see the structure of everything, the universe would look almost like foam, bubbles of emptiness surrounded by thin films of light. Each bubble is a cosmic void, and together they form the scaffolding of reality. For decades, astronomers didn't realize we were standing near the edge of one. But when they charted the motion of galaxies around us, they noticed something odd. Many of them seemed to be moving away from a certain direction, as if an invisible hand were pushing them outward. That invisible hand wasn't a force. It was the absence of one. The local void contains so little matter that its gravity is weaker than the regions around it, creating a gravitational imbalance. Galaxies at its edge, including ours, are drawn gently outward toward denser areas of the cosmic web. We are being nudged, ever so slowly, not by a push, but by emptiness itself. That's the paradox of the cosmos. Even nothing has influence. Gravity doesn't just pull, it also reveals where something is missing. A void expands not because it grows, but because everything else around it pulls harder. And in this strange dance of attraction and absence, the structure of the universe is written. Luminous bridges connected by darkness, each void carving its quiet presence into the map of eternity. For cosmologists, this discovery changed everything. Until recently, the universe was assumed to look the same everywhere on the largest scales. An idea called the cosmological principle. It's the foundation of all our cosmic measurements. The rate at which the universe expands, its age, its energy balance, even the physics of the Big Bang itself. But what if that assumption isn't quite true? What if our corner of the cosmos is different? Emptier, quieter, distorted by the vacuum around it? That question leads to one of the biggest mysteries in modern astronomy, the Hubble tension. For decades, scientists have tried to measure how fast the universe is expanding. When they study the oldest light, the faint afterglow of the Big Bang, known as the cosmic microwave background, they find one number. But when they measure the expansion using galaxies near us, they find another, a faster one. Two answers to one question, both apparently correct. It's as if the universe is expanding at two speeds at once. So what if the contradiction isn't in the data, but in the perspective? If we live in a large underdense region, a cosmic void, then light traveling toward us from distant galaxies moves through less matter than expected. It stretches slightly differently, and that difference could make the universe look like it's expanding faster from where we stand. The cosmos, in other words, might not be tricking us. It might just be uneven, and we happen to live in the hollow part of its design. It's an unsettling but strangely poetic thought. For centuries, humanity has been moving away from the center, first from Earth, then from the solar system, then from the galaxy. And now, in a twist of cosmic irony, we may have discovered that we are once again at the center, not of everything, but of almost nothing. Our home might be a bubble of silence adrift in a universe of light. And yet, there's something comforting about that. It reminds us that emptiness is not absence, it's structure. The universe is built as much from the spaces between things as from the things themselves. We exist not despite the void, but because of it. Every galaxy, every atom, every life that's ever looked up at the stars is shaped by the invisible geometry of nothingness surrounding us. So tonight, as we begin this story, imagine that great emptiness, not as a void to fear, but as a mirror reflecting how fragile and extraordinary our position truly is. We are floating on the edge of nothing, watching everything unfold around us. And in that nothing, perhaps, lies the quietest truth the universe has ever told. If you could look at the universe from the outside, it would not look flat or random. It would look alive, a glowing web of light woven through vast stretches of darkness. Each strand in that web holds hundreds of billions of stars, clustered into galaxies, connected by gravity and time. Between those strands lie enormous gaps, the cosmic voids. And it was within those gaps that one of the most profound revelations of modern science was hiding. For much of history, astronomers believed the universe was smooth on large scales. Galaxies, they thought, should be spread evenly like grains of sand scattered across an infinite beach. But in the late 20th century, that illusion began to dissolve. As telescopes became more powerful, scientists could map galaxies farther and farther away, not as dots in the sky, but as points in three-dimensional space. When those maps were plotted, something unexpected emerged. The galaxies were not random at all. They formed patterns, long filaments, walls, and clusters, leaving behind enormous holes where there was almost nothing at all. It was one of the first times humanity saw the architecture of the universe. The discovery came to life in the 1980s with the CFA Redshift survey, a groundbreaking project that measured how fast thousands of galaxies were moving away from us. By using the Doppler effect, the same principle that changes the pitch of a passing siren, astronomers could turn those velocities into distances. When they plotted them in space, they saw shapes, arcs and waves of galaxies wrapping around what appeared to be immense cavities. They had found the first clear evidence of cosmic voids. Those voids were not small. Some stretched hundreds of millions of light years across, dwarfing every structure we had ever known. One of the most famous, the Booter's Void, contained almost nothing. A region of space so vast that if the Milky Way sat at its center, no other galaxy would be visible in any direction for hundreds of millions of light years. It was not a gap between galaxies. It was an ocean between islands of existence. At first, scientists didn't know what to make of it. The cosmic voids didn't fit easily into existing theories of how the universe formed, but slowly, patterns began to emerge. Cosmologists realized that the voids were not mistakes or anomalies. They were a natural part of cosmic evolution. After the Big Bang, the universe was almost perfectly uniform, filled with tiny ripples in density. Over billions of years, gravity amplified those ripples. The denser regions pulled matter inward, forming galaxies and clusters. The less dense regions emptied out, expanding into the voids we see today. The universe had not simply grown, it had sculpted itself. In this new view, emptiness was not a flaw in the design. It was the design. The universe expands unevenly because it began unevenly, and those small variations became the great cosmic web. A pattern both chaotic and beautiful, written across hundreds of billions of light years. As technology improved, astronomers could map this structure in greater detail. Telescopes like the Sloan Digital Sky Survey traced more than 1 million galaxies, building a three-dimensional atlas of the cosmos. When the data was visualized, it looked like a network of veins or lightning frozen in time. Galaxies flowing along invisible filaments, converging in nodes called clusters, with vast empty chambers between them. We were finally seeing the skeleton of the universe itself. And yet, among all those structures, our position turned out to be strangely special. The Milky Way and the galaxies nearby sit at the edge of one of those hollows, a vast region known as the local void. It stretches more than 150 million light years across, an enormous underdense bubble that shapes the movement of galaxies all around it. The Milky Way sits between that emptiness and another dense region called the Virgo supercluster, a massive gravitational hub pulling thousands of galaxies toward it. In this delicate balance between attraction and emptiness, our cosmic address was written. To understand how this void influences us, imagine the universe as a landscape of hills and valleys, where gravity is the terrain. The dense regions, clusters and superclusters, are hills, places where matter gathers. The voids are the valleys where the pull is weaker. Objects tend to roll downhill toward the hills, leaving the valleys emptier with time. Our galaxy lies near one of those slopes, drifting gently toward denser regions, while the void behind us expands ever wider. That motion is measurable. When astronomers study the motion of galaxies, they find that the Milky Way and its neighbors are moving at hundreds of kilometers per second relative to the cosmic background radiation, the leftover glow from the Big Bang. Some of that motion is caused by the pull of massive clusters ahead of us, but part of it comes from the push of the local void behind us. The galaxies in that direction are moving away faster than average, not because something is pushing them, but because there's so little gravity there to hold them back. This discovery reshaped our understanding of cosmic motion. We often think of gravity as the only force that matters in space, but the absence of gravity, the voids, can be just as influential. Nothingness itself can sculpt the behavior of galaxies, steering their paths across millions of light years. It's a reminder that in the universe, even silence has structure. For cosmologists, mapping these voids became essential for another reason. When light from distant galaxies travels to us, it doesn't move through an empty vacuum. It crosses this uneven cosmic terrain. Passing through dense regions slows it slightly, while traveling through voids allows it to stretch more freely. This distortion subtly changes the redshift, the stretching of light, that we measure when calculating how fast the universe expands. In other words, where we are within this web can affect how we see the universe itself. That idea leads to one of the most humbling realizations in science. Every observation we make, every measurement of time and distance, is filtered through our position within the cosmic structure. If we live inside a void, then our measurements of cosmic expansion might appear faster than they truly are. This could be part of the reason scientists are struggling to reconcile the different values for the universe's expansion rate. The Hubble tension. The discrepancy might not mean that the universe is inconsistent, but that our vantage point is. When you think about it that way, our place in the universe becomes both ordinary and extraordinary. We are not at the center of creation, nor are we at its edge. We are somewhere between fullness and nothing, balanced on the thin thread between light and dark. The universe is vast beyond measure, yet our small corner of it tells a story written in its own shape. A story of expansion, of imbalance, of delicate asymmetry that has guided everything we see. And what makes that story so beautiful is that it reminds us of a simple truth. The universe does not need to be uniform to be complete. It can be uneven, lopsided, imperfect, and still produce stars, life, and wonder. The voids, as empty as they seem, are part of the harmony. They are the pauses between the notes, the quiet that lets the music exist. When scientists gaze into the dark and chart those invisible spaces, they are not studying nothing. They are listening to the rhythm of everything, a rhythm that hums across billions of light years and quietly includes us within it. When you imagine the universe expanding, it's easy to picture something simple, galaxies drifting apart like specks on a stretching balloon. But the truth is far less smooth. The expansion of the universe is not even. It ripples through a landscape of gravity and emptiness, where matter and void constantly shape each other. The universe grows unevenly, like dough rising faster in some places and slower in others, guided by the invisible architecture of its own past. In this grand design, cosmic voids play a quiet but powerful role. They are not just empty spaces between galaxies. They are the engines of cosmic motion. Each void, though seemingly still, is expanding, not because something inside it pushes outward, but because everything around it pulls away. The denser regions, rich with galaxies and clusters, exert more gravity, drawing matter toward them and leaving the voids behind. Over billions of years, those voids stretch wider, deepening into bubbles of almost pure nothingness. The result is a universe that looks like lace, luminous threads of galaxies framing vast, transparent hollows. If you could watch time unfold like a film played in reverse, you would see those voids shrinking and fading, their edges collapsing as gravity pulls matter back into balance. You would see the web rewinding into uniformity, a smooth sea of hydrogen gas just after the Big Bang. Then, as the film plays forward again, tiny quantum fluctuations, minuscule variations in density, would begin to amplify. The dense spots would grow denser, pulling in more matter, while the empty spots became emptier. That imbalance, born in the universe's first breath, is what sculpted everything we now see. The cosmic web that fills the universe today is therefore a fossil, the frozen trace of ancient ripples in the fabric of existence, and inside that fossil lies one of the deepest questions in modern cosmology. If voids are expanding faster than the rest of the universe, could they be distorting the way we measure cosmic time itself? Astronomers rely on light to understand the universe, but light is a storyteller that carries its experiences along the way. When it passes through dense clusters, gravity bends it, stretching its path. When it crosses a void, the journey changes again. It travels more freely, but in doing so, its wavelengths stretch differently than expected. These shifts are so subtle that they can only be detected with precise instruments, but their impact accumulates across billions of light years. A photon that began its journey when dinosaurs walked Earth might have passed through a dozen voids and filaments before reaching our telescopes, each passage warping its story just a little. This effect, called gravitational redshift, is part of what makes cosmology such a delicate science. We don't just measure the universe, we measure how it measures itself. And if we happen to be inside one of those underdense regions, the light we see may tell a story that's slightly biased toward emptiness. Distances might seem longer, and the rate of expansion faster than they truly are. That's why some scientists now wonder if the so-called Hubble tension, the ongoing disagreement between local and cosmic measurements of expansion, might not be a mystery of physics at all, but a consequence of geography. Perhaps we are standing in a cosmic valley, mistaking the slope beneath our feet for the shape of the whole mountain. If that is true, it wouldn't mean that our measurements are wrong, only that they are incomplete. It would mean that the universe is telling us the truth, but only from its local dialect, shaped by the void that surrounds us. The problem isn't the message, it's our translation. But there's more to it than numbers. Voids don't just distort our view of the universe, they influence its future. Because they expand faster than average, they accelerate the separation of cosmic structures. Galaxies near the edges of voids are slowly being drawn toward denser regions, leaving the emptiness behind. Over billions of years, the voids merge, creating ever larger bubbles of nothingness. If the process continues indefinitely, the cosmic web itself could become thinner and more fragmented, until distant galaxies fade beyond visibility, leaving each cluster isolated in its own dark bubble. That future is not hypothetical. It's already happening. Astronomers looking billions of light years away are peering into the universe's past, when galaxies were closer together and the cosmic web was tighter and brighter. The universe we see today, with its vast voids and long filaments, is a later chapter, one where expansion and emptiness have already begun to take over. Given enough time, even the faint light of neighboring galaxies will slip beyond our horizon, stretched until it disappears. What remains will be local, our galaxy, our group, and the memory of everything else. It's haunting to think that the universe's structure may contain the blueprint of its own solitude. The very process that creates beauty and diversity, the clustering of galaxies and the growth of voids, also guarantees that eventually every region of space will drift into silence. Emptiness wins in the long run, but that doesn't make it tragic. It makes it meaningful, because it means that every image we take, every map we draw of the cosmic web, is a portrait of something fleeting, a universe caught in the act of becoming. Our place within that act is uniquely poetic. The Milky Way lies right at the border between fullness and nothing, between the gravitational pull of the Virgo supercluster and the quiet expansion of the local void. We are balanced between attraction and release, between the gravity that holds us and the emptiness that lets us drift. It's almost as if the universe has placed us in the perfect vantage point to watch its own unfolding. From that edge, everything looks balanced, the visible and the invisible, the dense and the empty. Perhaps that's why our measurements of the universe's expansion are so precise and yet so uncertain. We are observers standing in a half-lit room, trying to judge the brightness of the stars through the haze of our own shadow. But maybe there's something beautiful in that limitation. Science is not the art of certainty, it's the art of wonder. The fact that we can detect these cosmic voids at all, that we can trace their boundaries and feel their influence, is a testament to how far we've come. We have mapped the places where nothing exists and found meaning in their silence. We have turned absence into evidence, darkness into knowledge, emptiness into understanding. Perhaps one day, when our instruments become even sharper, we will measure the exact influence of our void, how much it bends the light, how subtly it reshapes our perception of the cosmos. Until then, we drift at its edge, watching galaxies move like slow tides across eternity, feeling the faint gravitational whisper of the nothingness behind us, and maybe, in that quiet pull of emptiness, we can hear the universe reminding us of its most intimate truth, that everything, even the void, is part of one vast, connected story. If you stand beneath a truly dark sky, one untouched by city lights, you can see the structure of the universe with your own eyes, not directly, but in the quiet pattern of light and absence between the stars. The Milky Way, that bright river across the night, is only a small piece of a far larger web, a thread in a cosmic tapestry that stretches beyond imagination. And somewhere in that vast web, hidden behind the light, lies the invisible hollow that scientists call the local void, the quiet gap in which our galaxy drifts. But how do we study something that, by definition, is almost empty? How do you map a silence? The first step was to understand that voids reveal themselves not through what they contain, but through what they push away. Galaxies around a void move slightly faster, drawn toward regions of higher density. Their trajectories carry the signature of emptiness, a kind of cosmic fingerprint that scientists can read through motion. It's not the void we see, but its shadow, the way it reshapes the rhythm of everything nearby. The earliest attempts to detect voids relied on mapping the positions of galaxies and measuring their redshifts, the telltale stretching of light as they move away from us. Astronomers plotted millions of galaxies on three-dimensional charts, turning the universe into something that could finally be seen, not as a flat image, but as a living structure. When they visualized those maps, the cosmic web appeared. Glowing threads connected like neurons, surrounding enormous spherical gaps. It was in those gaps that the voids lived. As surveys expanded, the maps became more detailed. Projects like the Sloan Digital Sky Survey and the 2DF Galaxy Redshift Survey gave us not just dots on a page, but a dynamic, evolving view of the cosmos. Each void could now be measured, its size, its shape, even its influence on the galaxies around it. Some were almost perfectly spherical, others elongated like tunnels connecting clusters. Most were enormous, tens to hundreds of millions of light years wide. And together they accounted for the majority of the universe's volume. Empty space, it turned out, made up most of everything. The local void, our particular hollow, revealed itself slowly. By tracking the motion of nearby galaxies, scientists noticed a consistent pattern, a kind of drift. Galaxies within one direction seemed to move away faster, while those in the opposite direction appeared to fall toward dense regions like the Virgo cluster. It was as if we were standing on a slope, the emptiness behind us allowing the denser universe ahead to pull more strongly. This subtle imbalance, measured across millions of light years, became the first proof that we live on the boundary of a cosmic cavity. The challenge, however, goes deeper than motion. Voids don't just shift galaxies, they also warp the light that passes through them. Photons traveling across space carry with them the story of where they've been. As they move through clusters of galaxies, gravity bends and delays them, a phenomenon known as gravitational lensing. But when light travels through a void, something opposite happens. With less gravity to slow it, light slightly accelerates, stretching its wavelength more than expected. Over billions of years, these differences can accumulate, subtly altering how we perceive the expansion of the universe. Scientists can detect this through a process called the integrated Sachs-Wolf effect. It's an elegant concept. As light from the cosmic microwave background, the oldest light in existence, passes through a void, it loses a tiny bit of energy, like a whisper fading in thin air. When that light reaches us, the lost energy shows up as a faint cooling in the cosmic background map. By studying these temperature shifts, astronomers can pinpoint where the largest voids lie, even across billions of light years. In this way, nothingness becomes visible, not as darkness, but as absence written in the oldest light. Each void tells part of the story of cosmic evolution. When the universe was young, matter was more evenly spread. Over time, gravity gathered matter into filaments, leaving behind pockets of thin density. Voids grew like bubbles in rising dough, merging and expanding as the universe itself expanded. Their walls, the cosmic filaments, became denser and more complex, hosting galaxies, stars, and life. The voids, in turn, became the breathing spaces between those walls. Without them, the structure of the universe would collapse under its own gravity. The emptiness is what allows creation to hold its shape, and that realization changes how we think about our place in it. We don't just live on a planet orbiting a star. We live inside a galaxy that floats at the edge of an immense hollow in the fabric of existence, a place defined more by absence than presence. When we look out into the night sky, we're not looking into a full universe. We're looking across its scars, its gaps, its quiet rooms. It's almost poetic to think that everything we see, every distant light, every story we tell about the cosmos is framed by the nothingness surrounding it. But this nothingness isn't neutral. It shapes the very way we interpret the universe's expansion. For decades, scientists have tried to determine how fast the cosmos is growing, a number known as the Hubble constant. The results have been divided. One value from the early universe's light, another from galaxies near us. This tension, the Hubble tension, remains one of astronomy's deepest puzzles. Some think it points to new physics, perhaps even dark energy behaving differently than we imagine. Others suggest a simpler possibility, that the difference is born of our environment. If we live in a large, underdense region, a cosmic void, then the local space around us is expanding slightly faster than the cosmic average. That means our measurements of nearby galaxies would naturally appear too high. The contradiction in that view isn't cosmic. It's local. It's not the universe that's broken. It's our vantage point. This possibility is both humbling and thrilling. It means that the very structure of space, the invisible geometry of voids and filaments, can shape the answers to our biggest questions. Every calculation we make, every distance we measure, is influenced by the landscape we inhabit. We are, in a sense, scientists studying the forest while standing inside one of its clearings. The view seems wide, but it is framed by the emptiness around us. Even now, researchers are using new telescopes and simulations to refine this cosmic map. In Hawaii, Chile, and space itself, surveys are tracing galaxies in all directions, building the next generation of cosmic atlases. Supercomputers recreate the birth of the universe, letting virtual voids grow and merge until they resemble the patterns we observe. Each simulation brings us closer to understanding how these vast hollows formed, and how they continue to shape the rhythm of cosmic expansion. It is strange, isn't it, that the great mystery of the universe, the thing that might hold the key to its age, its fate, and our place within it, is not a force or an explosion, but an emptiness. A silence so vast it can alter time itself, and maybe that's the beauty of it. In the end, the universe is not built only from light and matter, but from contrast, from the spaces between. The galaxies give it texture, but the voids give it breath. And inside that breath, we find our own reflection, fragile, finite, and endlessly curious. When scientists first realized that the universe was expanding, it seemed like the simplest thing in the world. Galaxies moving away, space stretching between them, time unfolding like a tide that would never return. But as our instruments grew sharper and our observations more precise, a new truth emerged, one that defied logic. The expansion wasn't slowing down, it was speeding up. Something invisible was pushing the universe apart, an unseen pressure woven into the fabric of space itself. We gave it a name, dark energy. To this day, dark energy remains one of the greatest mysteries in science. We don't know what it is or why it exists. We only know that it accounts for nearly 70% of everything. Not just the stars, the galaxies, or the voids, but the very space that contains them. It's the quiet force behind cosmic acceleration, the invisible breath expanding the voids and stretching the cosmic web ever thinner. And so, the question arises, what if these voids, the enormous hollows between galaxies, are not merely shaped by dark energy, but are the very places where its influence is revealed most clearly? Perhaps the emptiness is not a side effect of expansion, but its stage. Maybe it's in those silent, airless regions where the universe's true nature whispers loudest. Astronomers began to notice something subtle. When they compared how galaxies moved near voids to those near dense clusters, they saw different patterns. In regions of high density, gravity fought against expansion, slowing it, even slightly reversing it in places where clusters were bound together. But inside and around voids, the opposite occurred. Space itself seemed to stretch faster, like elastic pulled thin. It was as though the voids were small, laboratories where the laws of cosmic acceleration could be watched in slow motion. If dark energy is truly a property of space, a pressure that grows, stronger the more space there is, then the voids, being vast and empty, should feel its presence most acutely. They expand faster than the rest of the universe, amplifying its effect. In that way, the voids are not just emptiness. They are mirrors reflecting the nature of dark energy itself. Some scientists have even begun to call voids the clean rooms of cosmology. Unlike galaxy clusters, they are unpolluted by complex gravitational interactions. They offer a pristine environment where the expansion of space can be measured without interference. By studying the shapes and growth rates of voids, cosmologists can test whether dark energy behaves as a constant force, the same everywhere and forever, or whether it evolves, changing its influence over time. The answer could determine the fate of the universe itself. If dark energy is constant, the cosmos will continue expanding forever, its voids growing until galaxies drift beyond sight and the stars burn out. But if it changes, if it grows stronger, then even the galaxies themselves will be torn apart. Atoms separated by the acceleration of space-time. The universe would end not in fire, but in silence, dissolved by its own expansion. It's a sobering vision, yet there's beauty in it too, because it reminds us that emptiness is not just absence, but potential. It is the part of the universe still unfolding, still expanding, still alive with mystery. Every void is a window into the universe's deepest nature, the place where we can watch the pulse of reality itself. The local void, our own cosmic neighborhood, offers a smaller reflection of that grand truth. Our galaxy sits on its edge, caught between attraction and release, the pull of the Virgo supercluster on one side and the vast stillness of the local void on the other. That tension between something and nothing defines our place in the cosmos more than we realize. It influences how our galaxy moves, how we measure time and distance, even how we interpret the universe's acceleration. The emptiness around us might be distorting our view, bending our perception of expansion like heat rising from a desert horizon. If we could step outside our galaxy and look back, we might see our cosmic home not as the center of motion, but as a leaf floating on a current of invisible pressure, a current shaped by the void behind it. That invisible push could make nearby galaxies appear to race away faster than they should, exaggerating the expansion rate we measure. Some researchers believe that this alone might explain part of the mysterious Hubble tension, the disagreement between the early and local measurements of cosmic expansion. Maybe the universe isn't broken. Maybe it's simply uneven, and we happen to live in one of its lightest regions. The thought is both humbling and thrilling. It reminds us that our measurements, no matter how advanced, are always local, always framed by where we stand. When we look into the sky, we're not observing the universe from nowhere. We're seeing it from within, through the subtle lens of our own cosmic surroundings. Even our understanding of time itself might carry the imprint of the void we inhabit. And yet, there's something poetic about this limitation. It means the universe has given us a vantage point that is not perfect, but human. A perspective balanced between the fullness of existence and the quiet of nothingness. Our instruments may not be able to see the entire truth, but they reveal enough for us to feel its shape, to sense the delicate symmetry of what lies beyond reach. In a way, the voids bring us closer to understanding the true nature of reality. They remind us that creation and absence are not opposites, but partners. Every star exists because somewhere else, matter was taken away. Every galaxy shines because gravity pulled it from the hollows that now surround it. Without emptiness, there would be no structure, no contrast, no place for light to live. The universe, at its core, is a balance between being and not being, and both sides are essential. This is why, when astronomers peer into those silent regions, they are not looking for nothing. They are looking for the laws that make everything possible. The voids tell us that space is not just a backdrop for matter. It is an active participant, shaping the fate of everything it contains. The emptier the universe becomes, the faster it expands. Emptiness feeds acceleration. Absence drives motion. It's a paradox that defines everything. So when we think about dark energy, that unseen force pulling the universe apart, perhaps we should imagine it not as something foreign or external, but as the quiet side of existence itself. It is the echo of balance, the voice of the void, the invisible partner to light and matter. And in that whisper, faint and endless, lies the secret rhythm of the cosmos, the heartbeat of nothingness creating everything. When you look at the night sky, what you see is not what is. Every star, every galaxy, every glimmer of light is a message from the past, a photograph taken millions or billions of years ago, still traveling across the quiet. The universe we see is a memory, not the living moment, but the afterglow of everything that has ever been. And as it turns out, where we stand within that universe determines which memories we receive and how they appear. If we truly live inside a vast cosmic void, then even our sense of time and distance is bent by that emptiness. Space here expands slightly faster than it does in denser regions, which means that light passing through our part of the universe stretches more, its wavelengths pulled longer, its colors soften toward red. This subtle effect changes how we measure distance, brightness, and even the age of the cosmos. The same galaxy, viewed from another place in the universe, might appear a little closer or a little older than it seems from here. It's a quiet distortion, too faint to notice with the eye, but large enough to trouble our equations. When astronomers use the light of distant galaxies to calculate the expansion of the universe, they rely on a few special types of cosmic beacons, stars and supernova whose brightness we can predict. By comparing how bright they appear to how bright they should be, scientists estimate how far away they are. But if the light from those stars travels through uneven space, through voids, filaments, and clusters, its journey is not uniform. It slows down in dense regions, then speeds up again in empty ones. The result is a cosmic mirage, an image of expansion that may not match the universe's true rhythm. Inside our local void, this effect is especially pronounced. Because the region around us is less dense, space itself is expanding faster here than in the cosmic average. That makes nearby galaxies appear to race away more quickly, skewing the measurements we take from them. It's as if we're standing in a valley where the ground itself is gently rising, trying to judge the movement of clouds above, not realizing that the world beneath our feet is shifting too. To correct for this, astronomers have begun to create vast computer simulations, digital universes filled with virtual galaxies, voids and filaments, to see how local conditions shape what we observe. In those models, scientists can place a virtual observer inside a void like ours and watch how their measurements change. The results are striking. Observers inside a large, underdense region often perceive the universe as expanding faster than it truly is. Their local Hubble constant is higher, not because the cosmos is speeding up, but because their patch of space is thinner, lighter, and stretching more quickly than the rest. This discovery adds a layer of humility to cosmology. It suggests that our most fundamental cosmic numbers, the age, the expansion rate, even the apparent acceleration of the universe, are shaped not only by what the universe is, but by where we are within it. We are, in a sense, trying to map the ocean while floating inside one of its waves. Our data is not wrong, it's just deeply personal, but the influence of the void goes beyond distance and expansion. It also affects how we perceive the shape of the universe. In Einstein's theory of general relativity, matter tells space how to curve, and space tells matter how to move. Dense regions, heavy with galaxies, curve space-time inward like dimples in a fabric. Voids do the opposite. Their lack of mass means less curvature, which makes light travel differently through them. Photons passing through a void take slightly straighter paths, bending less than expected. This changes the apparent alignment of galaxies, the way cosmic background radiation looks, even the geometry we use to describe the cosmos. When cosmologists map the universe using the ancient glow of the cosmic microwave background, that faint, uniform radiation left from the Big Bang, they're essentially reading the universe's oldest photograph. But the light from that photo has traveled through billions of years of structure, through clusters and voids, through gravity and time, each adding tiny distortions. By the time it reaches us, the picture has been subtly stretched, blurred, and curved. Some of those distortions are the fingerprints of the voids themselves. By analyzing these patterns, scientists can reconstruct the distribution of emptiness in the universe, like tracing the invisible air currents of a storm. The faint temperature fluctuations in the cosmic microwave background, sometimes only a few millionths of a degree, tell us where the great hollows lie, how large they are, and how they've grown over cosmic time. Our local void in that map is just one bubble among thousands, a small piece of a universal pattern repeating across the cosmos. It's strange to think that these voids, once invisible, now form one of the most precise tools we have for understanding reality. By measuring how they distort light, how they push galaxies, and how they expand, scientists can test the fundamental physics of the universe. If voids behave differently than predicted, if their growth rate or shape changes unexpectedly, it might reveal that our models of dark energy or gravity are incomplete. They might even point toward new physics, new forces, or dimensions we haven't yet imagined. Some researchers have gone further, suggesting that what we call dark energy might not be a separate substance at all, but simply the collective effect of cosmic structure itself. As matter clumps together, the surrounding voids grow emptier, and that imbalance could mimic the effect of an accelerating universe. In this view, the universe doesn't need a mysterious force pushing it apart. It only needs contrast, enough difference between the dense and the empty to create an illusion of acceleration. Whether or not that's true, it's a reminder that sometimes the simplest explanations hide in plain sight. The universe may not be adding energy, it may just be rearranging it. From a philosophical perspective, this all feels strangely intimate. We're used to thinking of emptiness as nothing, a lack, a void. But in the language of the cosmos, emptiness is alive with consequence. It bends light, shapes time, and defines how the universe grows. It is not passive, it is creative. Every atom, every planet, every pulse of light exists because there is space for it to exist in. Even our thoughts, the awareness listening now, depend on that space. When you gaze into the night and feel the stillness between the stars, remember that stillness is not truly still. It is expanding, evolving, alive in its own silent way. You are surrounded not by nothing, but by the fabric of everything. It stretches and breathes, carrying the echoes of creation through every corner of existence. So yes, we may live inside a void, a cosmic hollow so immense that its edges are measured in millions of light years. But that emptiness is not absence. It is the medium through which reality unfolds. Without it, light would have no room to travel, time no space to pass, and matter no stage to dance upon. The void is not what separates us from the universe, it is what connects us to it. If you could stand outside the universe and look back, you'd see that every galaxy sits inside a bubble of solitude. Even the brightest clusters are surrounded by darkness. It is not the darkness of absence, but the darkness of distance. The quiet that keeps each island of light distinct. We live within one of those islands, at the edge of one of those hollows, suspended between presence and nothing. And somehow, that emptiness feels familiar. From our small world, the universe looks infinite. But infinity, it turns out, can be lonely. The deeper astronomers peer into space, the more they find that most of it is empty. Not metaphorically, but literally. Trillions of kilometers of nothing separate each thread of the cosmic web. The stars we see at night are not crowded neighbors. They are distant echoes, spread thinly across an unfathomable sea. Inside the local void, that loneliness becomes a kind of physical truth. Our galaxy floats on the border between light and silence. If you could travel outward through that void, the number of galaxies would thin until even the faintest smudges disappeared. After a few 100 million light years, there would be no landmarks, no constellations, no direction, only the dim radiation of the cosmic background and the hum of your own instruments. To imagine such a journey is to confront the scale of existence itself. The void is not hostile, it is indifferent. It does not care that we live at its edge, or that we are trying to understand it. It simply is, a vast region where gravity never gathered enough matter to build light. And yet, from that emptiness comes meaning, because without those silent regions, the bright ones could not exist. The universe is balance written across eternity, light and dark, fullness and absence, motion and stillness. Our existence inside a void is not a cosmic accident. It is part of that balance. We are the observers placed in the pause between notes, listening to the symphony of creation play around us. Scientists have begun to study not only what this means for measurement, but for perspective. If most of the cosmos is made of emptiness, then life itself is an anomaly, a flicker of organization in a sea of silence. That realization changes the emotional gravity of science. The equations stay the same, but the feeling behind them deepens. To measure a void is to confront how fragile structure really is. The galaxies, the atoms, even thought itself are tiny victories against the overwhelming tide of nothing. And yet, the void gives us something profound: perspective. From the edge of this hollow, we can see farther, think longer, and feel more deeply than we ever could if the universe were crowded. Emptiness gives clarity. It is the quiet between the words that lets meaning form. Without the void, the story of existence would have no rhythm, just noise. Astronauts sometimes describe a similar sensation after returning from space. They speak of the overview effect, the moment when they look down and see Earth suspended in darkness, fragile and self-contained. For an instant, borders disappear. All conflict, all division, all illusion of separation dissolves. There is only one world, one atmosphere, one thin breath sustaining everything. Living in a cosmic void gives that same insight on a grander scale. From this vantage point, humanity itself becomes a single phenomenon, a brief sparkle in an endless field of black. It's easy to mistake that realization for despair, but it is not. It is wonder stripped of vanity. The void teaches humility better than any philosophy ever could. It reminds us that existence is not guaranteed. It is borrowed. The warmth of the sun, the chemistry of life, the stability of Earth's orbit, all depend on a precise balance of forces that could just as easily have gone another way. Out of endless silence came one small corner of light, and we are inside it. The more we study the void, the more it feels less like an emptiness and more like a mirror. It reflects everything we believe about meaning, scale, and connection. Some physicists have even begun to describe space itself as a kind of memory, a record of all the energy and motion that has ever passed through it. In that sense, the void around us is not empty at all. It's filled with history, with the faint gravitational echoes of galaxies that once were, with the afterglow of creation still cooling through its depths. Imagine those echoes, stretched thin across billions of light years, still tugging softly on the galaxies at their borders. That invisible pull is what keeps the cosmic web alive, a constant conversation between the seen and the unseen. Even silence participates. Every region of emptiness holds shape because of the structures around it, and every cluster holds shape because of the void pressing back. Balance again. On Earth, we experience the same principle in miniature. Every breath you take displaces air. Every sound depends on the silence that surrounds it. Even thought requires quiet to form. The macro and the micro echo each other, and in both, emptiness is never wasted. It is part of the design. When you think of it that way, the idea of living inside a cosmic void becomes strangely comforting. It means that our existence is balanced on the knife edge of possibility. Not random, but harmonious. The void does not diminish us. It defines us. It gives contrast to everything we are. Without it, there would be no awareness to notice, no sky to look through, no distance to measure wonder against. Perhaps that is why the universe feels both infinite and intimate. Because the same emptiness that stretches between galaxies also exists within atoms, within the spaces between particles, within the pauses between thoughts. The cosmos repeats its pattern at every scale. The void outside us and the silence inside us are reflections of the same reality. One vast, one personal, both essential. And maybe that is the real lesson hidden in all this science. To live inside a cosmic void is to live inside perspective itself. We are surrounded by nothing so that we can see everything. The universe placed us in emptiness so that meaning could emerge. So when you look at the night sky and feel that quiet pull, that faint ache of distance, don't see it as isolation, see it as invitation. The void is not what separates us from the universe. It is what allows us to belong to it. Every atom of your body was once scattered through those empty spaces. Every photon you see tonight has crossed that darkness to reach you. You are part of the conversation between something and nothing, a whisper carried across time. It's strange to think that the universe, in all its brilliance and violence, might be driven by silence. Every galaxy, every planet, every burst of creation unfolds inside a vast background of stillness, a silence so complete it holds everything together. And in that silence, the story of balance plays out again and again. For all the energy and light we see in the cosmos, there is always a counterweight, an equal measure of emptiness. Stars burn only because there are spaces for their light to travel. Galaxies spin only because the void around them allows motion to exist. Without absence, there would be no direction. Without stillness, there would be no rhythm. Physicists call this balance symmetry, and it is one of the universe's oldest languages. At the quantum level, matter and energy constantly trade places. Particles blink in and out of existence, their behavior ruled by probabilities rather than certainty. At the cosmic scale, that same principle stretches outward. The universe itself expands and cools in a dance between density and emptiness. Every structure that forms, from a hydrogen atom to a supercluster, owes its shape to the void that frames it. Our local void, then, is not a flaw in the design, but an expression of it. It is the universe remembering to breathe. As galaxies cluster and gravity deepens the wells of matter, something must expand to counterbalance it. That something is space itself, the growing pockets of nothing that keep the cosmos from collapsing back into itself. And in that growth lies the ultimate paradox of creation. The universe becomes more structured by becoming more empty. As the voids expand, the filaments between them sharpen, and galaxies are pulled into tighter threads. The emptiness defines the architecture. The nothingness sculpts the everything. When we look at deep field images from space telescopes, those haunting mosaics where every speck of light is a galaxy, we are not seeing a universe full of things. We are seeing a universe outlined by absence. Most of each image is black, and yet within that blackness hides the reason the light exists at all. Cosmologists often describe this as gravitational equilibrium, a dynamic tension between matter and space. Gravity pulls inward, binding galaxies, while the expansion of space pushes outward, separating them. Between these forces lies the delicate balance that allows time to flow as it does. If gravity had been stronger, the universe would have collapsed back into a single point long ago. If expansion had been faster, galaxies would never have formed. Instead, the cosmos tuned itself to the narrowest of margins, a harmony so precise that life could appear, think, and one day look back in awe. When we study the voids, we are really studying the universe's sense of proportion, its way of holding opposites in dialogue. Light needs darkness, order needs chaos, existence needs emptiness. Even consciousness in its quiet way depends on contrast. We notice thoughts because they arise from stillness. We see stars because they shine against night. Perhaps that's why the discovery of voids feels so human. They are not just features of space, they are metaphors made real. They remind us that what isn't there can matter just as much as what is. And that realization reaches beyond science, into philosophy, art, and meaning itself. For centuries, thinkers have debated why there is something rather than nothing. But maybe the question misses the point. Maybe the universe never chose between the two. Maybe it contains both in perfect balance. Creation and emptiness, side by side, interwoven like light and shadow. The cosmic void is proof that the universe didn't eliminate nothingness when it made something. It kept both, letting them coexist. The void is not the absence of creation. It is creation's other half. If you could drift to the center of one of those great voids, you might find the purest expression of that balance. No light, no warmth, no sound, only the slow expansion of space itself. But even there, you would not be alone. The faint gravity of distant galaxies would still tug at you. The cosmic microwave background would still bathe you in the afterglow of the Big Bang. Even in the deepest silence, there would be memory. The universe never truly forgets. This truth humbles even the most advanced cosmologists. No matter how precise our measurements become, no matter how far our telescopes see, we are always observing from within the story we're trying to read. We can map the voids, measure their size, predict their behavior, but we cannot escape them. They are the condition of our existence. We live inside the phenomenon we study. That circular truth has a quiet beauty to it. It means that our act of observing the void, of listening to it, is part of the same process that shaped it. Every photon we catch, every particle we measure, every question we ask becomes part of the pattern. The universe is not indifferent to awareness. Awareness is one of its outcomes. The void gave rise to light. Light gave rise to matter. And matter eventually gave rise to minds that could look back and wonder. So when we talk about cosmic emptiness, we're also talking about the space inside us, the pause between thoughts, the breath between moments, the silence before understanding. They are the same pattern repeating, scaled across different infinities. The void inside the atom, the void between galaxies, the void in the human heart. Each one is a reflection of the same principle. That meaning exists because of space, not in spite of it. As the universe continues to expand, that principle only deepens. The voids are growing, galaxies drift farther apart, stars age, and the sky slowly dims. In the far future, most of the light we see today will vanish beyond the cosmic horizon, unreachable forever. But even that disappearance has purpose. It ensures that the universe never runs out of contrast, that somewhere, even in silence, there will always be change. We often imagine the end of the universe as a tragedy, the lights going out, the stars fading, the cold closing in. But maybe it's not an ending. Maybe it's the universe completing its sentence. After all, every story needs a final quiet. Every piece of music needs a rest before the last note. And if this universe ends in darkness, perhaps it is only preparing space for another beginning, another expansion, another breath. The cosmic void, then, is not a warning of emptiness, but a promise of balance. It tells us that the universe is whole, not in spite of its silence, but because of it. The same silence that surrounds us now is what allows meaning to echo forever. There's a moment, if you stay awake long enough under a clear sky, when the universe begins to feel personal. The noise of the day fades and the stars stop feeling like distant things. They become presence, a quiet awareness that stretches far beyond thought. You realize you're not just looking into the universe, you're looking from within it. We spend our lives surrounded by space, and yet only rarely do we feel it. The air between breaths, the pauses between words, the long silence after something ends, all of it mirrors the same emptiness that fills the cosmos. It's easy to forget that the majority of everything is made of nothing. Even the atoms that make up our bodies are mostly void. Between each proton and electron lies a gulf so vast proportionally that the human body is almost entirely empty space. We are, quite literally, beings of light and emptiness, sculpted into brief form. The cosmic void and the human soul share this paradox. Both are shaped not by what they contain, but by what they leave open. Our consciousness, too, is a kind of space, one that allows thoughts, emotions, and sensations to arise and fade. Without that space, there would be no awareness at all. In that sense, the universe and the mind are not separate stories. They are the same phenomenon unfolding at different scales. Energy becoming aware of itself through contrast. The local void, that great hollow surrounding our galactic neighborhood, may seem like an abstract thing, an astronomer's curiosity, a coordinate on a cosmic map, but its existence touches everything we see. The emptiness behind our galaxy pulls on us with invisible hands, guiding our motion through the cosmic web. Every night sky we look at, every photon that reaches our eyes, has been shaped by that silent gravity. We are not simply living near a void. We are part of its motion. We are drifting within the rhythm of its expansion. It's humbling to realize that even our cosmic address is temporary. In a few billion years, the Milky Way will merge with the Andromeda Galaxy, forming a new system, an elliptical island of stars adrift in an ever-widening sea. By then, most of the other galaxies we can see today will have faded beyond our observable horizon. Future astronomers, if any exist, will look at the sky and see only one great galaxy surrounded by darkness. They will never know there were once trillions of others. The evidence of the cosmic web will be gone, dissolved into silence. But we know now. We are the first generation in all of cosmic history to understand the shape of the universe, to glimpse its structure, to recognize the voids, to name the hollows that hold us. And that knowledge carries a kind of responsibility. It reminds us that meaning does not come from abundance, but from awareness. We are not small because the universe is large. We are significant because we can feel its size. The deeper we study the void, the more it teaches us about empathy, about the strange beauty of coexistence between opposites. Where there is light, there must be darkness. Where there is matter, there must be absence. And where there is life, there must be space for it to unfold. Our entire existence depends on balance, the balance between chaos and order, between the visible and the unseen. Perhaps that's why, when people gaze at the stars, they often feel a mix of wonder and loneliness. It's not because the universe is empty, it's because some part of us remembers that emptiness, recognizes it as home. We come from it, return to it, and live our brief moments of brightness within it. The void is not the opposite of life. It is the space that makes life possible. Science often begins with questions, but the best discoveries end with silence, a kind of awe that no equation can fully describe. When scientists mapped the cosmic web for the first time, they didn't just find structure. They found poetry written in geometry. They saw that the universe was not random, but relational. Galaxies formed patterns. Light followed invisible lines of gravity. and between them stretched the voids, vast regions where the universe simply paused, as if taking a breath. That breath connects everything. It is the same pause that allows atoms to form, that lets stars ignite, that gives consciousness room to arise. And if you think about it long enough, it starts to feel like something more than coincidence. It feels like design, not in a mystical sense, but in a mathematical one. The kind of beauty that emerges when complexity organizes itself. The human experience mirrors that same principle. Our lives too expand and collapse, shaped by forces we can't see. We move through our own invisible structures: love, loss, curiosity, time. We build meaning in the spaces between moments, between people, between memories. In that sense, each of us is a microcosm of the universe, a small story of something vast, learning how to see itself. And so, the cosmic void becomes more than an astronomical curiosity. It becomes a reflection, a cosmic metaphor for awareness. We live inside it, yes, but we also carry it inside us. The same emptiness that fills the space between galaxies fills the space between our thoughts. It is the stage on which existence performs its brief and beautiful play. One day, this universe will grow so vast that even light will no longer cross its widening distances. The last stars will fade, the last photons will stretch into invisibility, and the void will reclaim its quiet dominion. But even then, the story won't be over, because everything that happens leaves an imprint, a subtle bending of space-time, a whisper in the fabric of nothingness. The universe remembers itself, even in silence, and maybe that's the most comforting thought of all, that even if everything we know disappears, every planet, every star, every trace of matter, the memory of existence will remain woven into the void itself. The emptiness is not forgetting, it is remembering differently. So when you look at the stars tonight, imagine that the darkness between them is not absence, but history. The quiet record of everything that has ever been. That darkness is alive with meaning. It carries the afterglow of beginnings, the stretch of expansion, the memory of light still traveling. You are part of that journey. You always have been. And perhaps, in that realization, the loneliness of the void transforms into something else entirely. It becomes connection. The understanding that even in silence we are heard. Even in emptiness we belong. Even in the great cosmic hollow, something inside us recognizes home.